In our last section of this solving systems unit, we are going to talk about some word problems. We're going to talk about developing actual equations. Now, when we talk about developing the equation, we really concern ourselves with how one relationship is associated with the second relationship. So how two variables are related to each other. Now, typically the easiest way to work with these is determine which type of information is different and make equations from that. So we're going to create some equations and then we're going to verify some things in this first example. After that, we're going to actually start doing some things and solving them. So our first thing is we're going to create a linear system for this system. So the perimeter of the Nunavut flag is 16 feet, but its length is 2 feet longer than its width. So we have two key bits of information. The thing that talks about the perimeter and something that's talking about how the length and width are related to each other. Now, you're not always going to be given situations where you're going to have everything completely identified in one line after the other. So we have to work with making sure that what we have is going to still be correct. So meaning what we're going to be doing. So whatever numbers we're going to work with, that they are actually properly related in the same equation. And you'll see what I mean in one of our later examples. So the perimeter of the Nunavut flag is 16 feet. Well, if we're talking about perimeter of a flag, well, let's see, a flag is a rectangle. So no matter what, we have a length, which is the same there, width, and if we want to talk about the perimeter being 16 feet, well, perimeter is the addition of all of these outside things, meaning if we take the length, sorry for the curly L, it's just to really identify that it's not actually a 1. We have 2 lengths plus 2 widths equaling 16. So what does that mean? Well, if we combine our like terms, 2L plus 2W gives us 16. Now the trickier one is this length is 2 feet longer than the width. So the length is 2 feet longer than the width. So there's two real ways of understanding this. Now obviously you can see from my picture that it's not drawn to scale. There's two ways of doing it. Either we can say the length, if we took 2 feet off of it, it would give us what our width is. Another way of dealing with that is we could say that the length is whatever our width is plus 2 feet. So those are our two equations. Now we're only going to deal with two equations at a time. If we were to get into the old matrices curriculum, then we'd probably have 3 systems and we'd actually have to solve with 3 variables. But we're kind of limited to grade 10, just dealing with 2 variables at a time. Now at the same time, I could switch these to x's and y's. I'm just going to use a variable that makes sense in this situation. So the rest of the question says that Denise has determined that the flag is 5 feet long by 3 feet wide. We're going to verify that the linear system is correct from part A. So we're going to verify that the system that we just created, so the 2 equations, are correct. So for example, if we had 2 feet length or 5 feet length and 3 feet width, well, two times 5 add 2, sorry. Two times 3 equals 16. Is that true? Well, 2 times 5 is 10. 2 times 3 is 6. Does 16 equal 16? Fantastic, we're good. Or if we talk about our length equaling width, add 2. Or we could obviously use these other equations over here because these are still good. We see that our length is 5. Is that equal to 3 plus 2? Yeah, we're good. So this would actually be our solution. Now, if you want to tie this back into what we've been talking about in section 1, 2, or 3, talking about the ordered pairs, well, length and width, in this situation, because we're not dealing with an x and a y, we'd have to identify and say that, yes, our length is 5 feet. And the width is 3 feet. Now let's get into the nitty-gritty. We're going to create and solve linear equations for the following 3 situations. A school has raised $140 by collecting 2,000 cans and glass bottles for recycling. The school receives 5 cents a can and 10 cents for a bottle. How many bottles and cans were recycled? So the reason that we go through solving an equation or creating a system here is that way we can identify everything without having to do a whole bunch of guessing and checking. Absolutely, some of you that are good at math and having logical reasoning, this may not be a very difficult question. But if we were to get into some situations where we have to create this system and solve it, and so you know, I have actually done this during summer projects. I have actually created systems and solved things out so I can stay on budget for different tasks and such. But this allows us to get a whole bunch of different information. Now, let's identify a few things. We'll say that C talks about cans, and a B talks about bottles. So the biggest thing that we need to do is we need to determine which type of information is different and make equations from that. In this question, we have 2 things. We're talking about money, and we're talking a number of cans and bottles. So again, just to outline that, we're talking about money, and we're talking about numbers. So we're talking about a number of material. So if we talk about just the money, well, what other part in this question talks about money? The fact that you're getting 5 cents for a can and 10 cents for a bottle. We can set up an equation for that. 5 cents for a can will be 5 cents for every single can that you turn into your recycling depot. In Saskatchewan, second. And 10 cents for a bottle is 10 cents for a bottle. Now, if you're however many cans and however many bottles get turned in, you're making $140. Well, where does this 2,000 cans and bottles come into effect? Well, that's actually our second equation. And this second equation means that if we have 2,000 cans and bottles, this is actually probably the part that's going to get it grown. However many cans plus however many bottles we turn in is this going to equal 2,000? After here, now we're going to actually solve it. So we've created it, now we're going to solve it. Of course, it does not matter which method you use. You could graph, you could solve by substitution, we could solve by elimination. Because we had spent our entire last unit on graphing, we're going to focus more on the substitution and the elimination, because being able to manipulate equations is going to be a must if you're going to be going into further foundations or pre-calculus 20 and their subsequent 30 level courses. Let's see, what would make the most sense? See, we could do some elimination. We could do substitution. Heck, it's not a bad question. Let's do it both ways. So on the one side, we're going to substitution. On the other side, we're going to do some elimination. So to do our substitution, now I'm just going to actually do some wonderful copying here. Move my page around. Just give me a second. There we go. Now I can take my equations. So on the left-hand side, I'm going to do substitution. Again, keeping in mind, no matter which method I use, I'm going to get to the exact same answer. So with this one, not sure why I don't have a pen here. Maybe I'll just go back out. No matter what. Okay. It doesn't matter which equation or which one here I do get by themselves. Either C or B, they're already a variable that's already by itself. Since C is first, I'll just get rid of the B. So I can subtract B from both sides. So C would equal negative B, add 2,000. So wherever I see C in the other equation, I'm going to substitute it in. So I get my 0.05 negative B plus 2,000 and 0.10 cents for a bottle. And then I can do my distribution. So 0.05 multiplied by B is negative 0.05 B. My 2,000 by my 0.05 is 100. Now I'm going to combine two steps in one. I'm going to subtract my 100. And I can combine my B terms together. Negative 0.05 B adding 0.10 B will be 0.05 B. That equals 40, which is 140 divided by, or sorry, subtracting 100. Divide by the 0.05. And B equals 800. Now that I know what my B is, I can use one of my other equations. Now it doesn't really matter which one, but this one already has to solve for C. If C equals negative 800 plus 2,000, it'd be 1,200. What that means is that there were 800 bottles recycled and 1,200 cans recycled. So there's a review of substitution. At the same time, I can do elimination. So in order to eliminate, I'm going to have to get one of my variables to have the same coefficient. Let's see, I have manipulated this side. I got my b by itself. Let's get rid of the b in this one, which means I'm going to have to multiply every single thing here by 0.10, which means I'm going to have 0.10c plus 0.10b, 2,000 by 0.10 is 200. I'm just going to bring down my other equation. That way I can do my elimination nicely. Let's see, 0.10c subtracting 0.05c. Well, that's 0.5c. 0.10 subtracting 0.10, gone. 200 subtracting 140 should be 60. Finish off my work by dividing by 0.05. And C is 1,200. Now, if by chance you wanted to go the hard way and you wanted to plug this 1,200 into the first equation, and go that method, you absolutely can. Let's see, so our 1,200 by 0.05. $60, continuing on. I can subtract my 60. Get 80 on the right-hand side. Divide by my 0.10. And our b value is 800. Therefore, what we had just done over here is the exact same answer over here. 800 bottles, 1,200 cans. Both methods, exact same answer. Okay, another equation. Alexia had invested $1,800. Since we have 2 bits of information, let's identify what our pieces of information are. Let's see, we have something to deal with money, interest percent, and more money. So I had Alexia had invested $1,800, some at 3%, and the rest at 4.5%. After 1 year, the earned interest was $73. How much was invested in each amount? So let's identify a few things. Let's say F is the first account and S is the second account. We could use X, we could use Y, it all works. So let's see. How much money? Let's see. We have something talking about the total amount that was invested, but then we have things that talk about an interest rate. And we have things that's talking about money that's an interest rate. So I mean that these things would have to be related. So we'd have to have some kind of relation. 3.5%, we have to divide by 100, we get 0.035. And 4.5% would be 0.045. That equals $73. So what are we going to do with this 1,800? Well, it just means however much money that she invested in the first, add however much money was in the second, would add up to be $100 or $1,800. Now I'm going to only show one method because it's going to save us a bit of time. So I just need to do one thing. And further on, we can keep on going. Let's see, I'm going to manipulate this. Let's see, what can I do? I'll subtract. I usually subtract the second one, but I can also subtract the first one. So that's meaning that our S would equal negative F plus $1,800. So wherever I see S in the equation, I'm going to put negative F plus 1,800. So I'm going to do a substitution in this one. Zero 0.045. And continue from there. I can get my 0.035. Continuing on. Let's see. Oh, that's not going to be add. That's going to be subtract. 0.045 by the 1,800. 81. Again, combine some steps, so I'm going to subtract 81 at the same time as subtracting these. So I get negative 0.01 F equaling negative 8. And finish off by dividing by the negative 0.01. My F value, 800. So if my F value is 800 and S is negative 800, add 1,800, it'd be 1,000, meaning, make that actually look nice. The first account. So if F means that Alexia had invested $800 in that first account. In the second account, will be $1,000. Now, of course, some of you may be asking the question of why would you be investing your money into a lower interest rate if you can see a higher? Well, there's a few different situations. For example, the first, you may have to invest a certain amount in a lower interest rate to earn the higher interest rate, or vice versa. You may have to invest a certain amount of money in the higher interest rate before you can put any kind of surplus in the second. There's multiple things. Same time, there are lots of happy bankers and mortgage and insurance and investment people that would be willing to help you with that kind of information. At the same time, a lot of your information is available right at your fingertips just by checking online. Okay, let's continue. So a farmer, now just so you know, this question is absolutely not very realistic. I understand. Just bear with me. It's a question that is found. Just try and get some more skills. A farmer had harvested one section of wheat and two sections of barley. The total yield of grain for both areas was 99,840 bushels. The wheat sold at $6.35 per bushel, and the barley sold at $2.70 per bushel. The farmer received a total of $363,008 in total. What was the yield of each section in bushels per acre? And keeping in mind that one section is approximately 640 acres. So let's identify the information and where all of our information is coming. So for example, we have something that's talking about money and receiving money. Then we have some information that's talking about bushels. So let's identify our money one first. We have, oh, maybe we should use a variable too. We'll say W is for wheat and B is for barley. $6.35 for wheat and $2.70 for barley. Now, all of the bushels that he sells, or she, earns a total of $363,008. Now, keeping in mind, there's a lot of overhead and a lot of money that goes into actually running a farm. So don't think that that's a large amount. Farmers do what they do because they love what they're doing. And we all have to be extremely appreciative of everything that they're doing. All right, continue on. Totally. Now, just this part talks about bushels. Well, no, there's no actual relation between one section of wheat and two sections of barley. That just means that's how many they've harvested. The total amount of grain for each of these bushels, just our wheat and barley, produces 99,840 bushels. Really quite basic and simple. Now, since I had done the last equation by substitution, let's do an elimination on this one. So it doesn't matter which one we eliminate. I am going to eliminate the B. So I'm going to multiply both of these by 270, which means then I'm going to have 2.70 W plus 2.70 B equals, use my trusty dusty calculator, 99,840 times by 2.70 is 269,568. Now, I don't necessarily need to rewrite my top equation. If I can understand and I can work with here, and I know that I am going to take this top equation and subtract everything in this bottom equation, I'm good as gold. I can take my 635 W and subtract my 270 to give me 3.65 W. 270B, subtracting 270B, well, that's gone. 363,008, subtracting 269,568. That's 93,440. So to finish things off, I divide by my 365. And the amount of grain, bushels that is obtained by the wheat, 25,600. If I want to find out what my barley yield is, well, I have 25,600 for my wheat. Add B, it's 99,840. Subtract off my 25,000. Sorry, I had gone back to this purple equation up at the top here. Just manipulate for my B value. 9,840. Subtract off that 25,600, and I get 74,240. So that's how many bushels of barley that was obtained. Now, that's not actually the end of this question, just because I wanted to make it a little more fun. Last question is, what's the yield of each section in bushels per acre? Well, bushels per acre, this is how many bushels was harvested. Bushels per acre, well, that's actually, we're just going to take our bushels and divide by the acres. So as a completely side question, for our wheat, a farmer had harvested one section of wheat. Well, one section of wheat is 640 acres. So we just have to take our 25,600 divided by 640. 25,600 divided by 640. Mess something up. 640. This farmer is getting 40 bushels per acre for wheat. If we do the same kind of calculation for barley, the only difference is there's two sections of barley. So we'd have to take our 74,240, two sections, each section being 640. That means that we'd be at 1,280, and 74,240 divided by 1,280. We get 58 bushels per acre. And there we have it. We've developed equations, we've solved them, we're reviewing our skills of substitution and elimination. Again, the only reason that we're not going by the graphic is because where on your grid are you going to have 801 or 801,000? Absolutely, you could have a 5-3. Where are you going to get 801,200? Or in the last question, 40 and 58. It's unrealistic to graph them. At least with our paper and pen graphing. So again, if you have a calculator or have your textbook, these are absolutely some fantastic questions. I have some more posted ready for you. All right, have some fun.